All right, this is section 7.4, solving systems of equations. So what we are going to be doing is solving equations for both variables. So we're going to solve one variable at a time is what we're going to do. So the first step is to look and see, do you have any variables isolated? So already starting off, we have y isolated. Y is by itself. So we're going to take each of these and set them equal to each other, which is essentially saying y equals y, which is true, like y would equal itself. So x plus 3 equals 2x plus 5. So what we're going to do is we're going to solve for x first. We're going to solve for x. So we need to, this is a multi-step equation. What would we do first? Well, we don't have any like terms on the same side.
Add 2x plus.
We can't add that.
Minus x.
I would subtract x from both sides. Because we're trying to get x's on one side, numbers on the other. So 3 equals x plus 5. Okay, now how would I solve for x?
Minus 5.
Minus 5. So x would equal
-2.
-2. Okay, so I am partially done. I've solved for x. Now I have to go back and solve for y. So I'm going to take x equals -2 and I'm going to plug it into either of these equations. So if I plug it into the top, I would have y equals -2 plus 3. Because x equals -2. So y would equal what? 1. Okay, so now I've solved both parts of the equation.
Then you got it.
No, those are my two answers. Okay, number 2. So we're going to go through this step by step. You're looking for, do you have a variable that is isolated?
Yes.
Y is isolated. So we are going to solve for x. We're going to set each of these equal to each other. So 3x plus 8 equals -7 plus 3x. Okay, so I'm trying to get x's on one side, numbers on the other.
You subtract 3x, but then what may be no solution?
Yes, so we're going to subtract 3x, and all of the x's then are going to cancel out, and we're going to be left with 8 equals -7. So does 8 equal -7?
No.
No, so this one, we would stop right here, and this would be no solution.
So you don't have to do the y part.
We can't, because we're not going to be able to get a solution for x. Okay, so next one, we have y isolated. So we are going to set these equal to each other. So 4x minus 6 equals x plus 3. So first, I would do what with my x's?
Minus x on each
Just
side.
separate.
So if I subtract x from each side, so I have 3x minus 6 equals 3.
And then just
Add 6. So 3x equals 9,
and then divide.
and then divide by 3.
This is 3.
Okay, so x equals 3, we're partially done with this problem. Now we have to take x equals 3, plug it back in to get y. So I'm gonna I can put it in either of these equations, it doesn't matter, but this one, the bottom one would be easier. So y equals 3 plus 3. So y would equal 6. Okay, so, I want you to pause your video and try this problem. All right, so for this problem, I would set 2x plus 9 equal to negative 7 plus 4x. I would start by subtracting 2x. So then I have 9 equals negative 7 plus 2x. And then my next step would be to add 7 to both sides. So 16 equals 2x. So then divide by 2. So 8 equals x. So then I have to take that and plug it back in to either of these equations. So if I use the top equation, I would have y equals 2 times 8 plus 9. So 16 plus 9 would be what? 25. Oh, that's there. Okay, so we would get x equals 8 and y equals 25. Okay, next problem. This one looks a little different because we don't start out with a variable already isolated. So we have to isolate a variable. My choice would be to isolate one of the variables that doesn't have a coefficient. A coefficient means a number in front. So either of these two x's would be easy to isolate. I would probably just go for the top equation because it doesn't really have a bunch of numbers to work with. So x minus y equals 3. So what I'm going to do is try to get x by itself. So I'm going to add y to both sides. So x would equal 3 plus y, because I can't actually add 3 and y. So x equals 3 plus y. Okay, now I'm going to take this and plug it in for x into the equation I didn't work with yet. So I have not worked with the bottom equation. So I'm going to take 3 plus y, and I'm going to substitute it right here for x. So that would give me 3 plus y plus 5y equals 39. Okay, so at this point, if you end up with more than one variable, like they're both y's, which is what we want, but if I would have ended up with an x and a y, I would have done something wrong. Because the whole entire point is to get the same variable in the equation so you could solve the variable. Okay, so now I need to combine like terms. So y plus 5y. So I have 3 plus 6y equals 39. Okay, then I need to subtract 3. So 6y equals 36. And then divide both sides by 6. So y would equal 6. Okay, so I still need to go back and solve for x. So I'm going to take y equals 6 and plug it into my equation. So x minus y equals 3. So x minus 6 would have to equal 3.
Nine.
Like what?
So x would have to equal 9. Okay. Again, on this one, we don't have any of our variables isolated. However, there's only one variable that doesn't have a coefficient, which is y, so on the top equation. So I would choose to isolate that, because that way I don't have to do any dividing or anything like that. So 3x plus y equals 8. So how would I get y by itself? Subtract 3x. So y equals 8 minus 3x. So we solve the equation for y. So we're gonna go and take and plug that into the equation we haven't worked with yet. So we haven't worked with the second equation yet. So I'm going to take y equals 8 minus 3x, and I'm gonna plug it in right there. For y. Okay, so I'm gonna have 6x plus 2, and then I need to put parentheses because I have 8 minus 3x to plug in. Parentheses equals 16. Okay, so what step would I need to do first? Distributive property, multiply. So I'm gonna carry down the 6x, and then I have 2 plus 8. Not 2 plus 8, 2 times 8, which is 16. 2 times negative 3x, negative 6x equals 16. And then what would I do next?
Combine like terms.
Combine like terms. So 6x minus 6x.
Zero.
0. So it equals 16 equals 16.
So that's yes.
So that is true. So what kind of solution is that?
Infinite.
Infinitely many. Okay. All right, so for this problem, again, neither variable is isolated. You can choose to isolate either one, it doesn't matter. If I go with the bottom equation and isolate for x. So if I'm trying to isolate for x, I would need to add 3y to both sides. So x equals 11 plus 3y. And I worked with the bottom equation, so I'm gonna have to take that and plug it into the top equation. So I'm gonna plug that in right here into the top equation. So that would give me 11 plus 3y, and then I still have that plus 4y equals negative 10. So again, at this point, you want to check and make sure that you have same variables across your equation. Because that's the whole entire goal, is to get only one variable solved at a time. So 11, and then we need to take 3y plus 4y. So 7y. So 11 plus 7y equals negative 10. And then what should we do? Subtract 11. So 7y equals negative 21. And then divide by 7. So y equals negative 3.
And what about it?
We have to still solve for x.
Okay.
Okay, so now we need to take that and plug it in and solve for x. So x minus 3 times negative 3 equals 11. So what is negative 3 times negative 3? So x plus 9 equals 11. So x has to equal 2.
So that's infinite.
No, that's y equals negative 3 and x equals 2.
We had to get 9. I thought it was good.
That's negative and negative.
No, not that, but how do you get X?
Because we
Minus
would
9.
subtract 9 from both sides and get x equals 2. Okay, last one. So in this problem, there is no variable that doesn't have a coefficient. All of them have a number in front. So personally, I would solve for the bottom equation because there's no negatives in the bottom equation. So if I solve for the bottom equation, it really doesn't matter which one you choose, but 4x plus 2y equals 20. We could solve for y. So I would start by subtracting 4x. So then I would have 2y equals 20 minus 4x. And I still need to get y by itself. So I need to divide everything by 2. So y equals 10 minus 2x. Okay, so that's what y equals, and we use the bottom equation. So I'm gonna take that and put it back in the top equation. And I'm gonna put it right there for y. So negative 3x plus 3, and then parentheses, and what y equals, which is 10 minus 2x, and then equals 12. Okay, so what I would do now would be distribute. So I'm gonna carry down the negative 3x and distribute the 3. So 3 times 10 is 30. And 3 times negative 2x is negative 6x equals 12. Okay, so then I need to combine like terms. So negative 3 minus 6 is negative 9x plus 30 equals 12. So then I have to subtract 30. So negative 9x equals,
Negative 16.
you're close,
18.
negative 18. So x would equal what? Positive 2.
What?
Negative 18 divided by negative 9. Okay, so I'm not exactly done. I have to take that and plug it back in to solve for x. So 4 times 2 plus 2y equals 20. So 8 plus 2y equals 20.
Minus 2.
So minus 8. So 2y equals 12. So y equals 6.
That's a lot of work.
So a good portion of the assignment has the variable already isolated, so those go a lot faster. So here is your homework. It is 1 through 24. So a couple of things I want to point out. There is only one no solution. Okay, there are no infinitely minis. So there's one no solution, no infinitely minis. Also, you have to show your work or you will receive 0 credit. If all you have is answers, you will not get any credit.
And where are we in?
1 through 4.